Hi everyone, meteorologist Joe Chaffee for meteorologistjoechaffee.com, weatherlongisland.com, and nycweathernow.com. Also for ssstormchasers.com, and you can bet that SS Storm Chasers will be on the scene here, and as Hurricane Matthew continues to move northwestward, you can see there is the hurricane. Looks like it's beginning to get a little better organized. I haven't seen too much change on the reconnaissance aircraft reports so far, but based on the water vapor imagery, we're starting to see a burst of convection going on the north side again as it continues to pull away from Cuba. There's a mountainous terrain in eastern Cuba, and that's disrupting the circulation to some degree, but as it starts to get a little bit further north and deeper into the central Bahamas, with water temperatures that are running at about 88, 89 degrees in some spots, and the fact that there's very low wind shear, once the circulation gets further away from the effect of the mountaintops here in eastern Cuba, and also even still being affected by some mountaintops in western Haiti, which go up to as high as 7,600 feet. So that does have some impact. We're going to see this strengthen almost. I think it has a shot of becoming a Category 4 hurricane once again. Top winds as of earlier this afternoon, 120 miles an hour. And you can see it on the wider view right here. You can pick out the eye on the visible satellite view. You can also see Tropical Storm Nicole east-northeast of Matthew, and still kind of staying separate and away from Matthew's circulation. At least that seems to be the case so far. And when we look at the view with regards to the northeast, Matthew is just coming into the picture here, and there's Nicole, and you can see the outflow from Matthew is still maybe just affecting probably the western side of Nicole with a little bit of wind shear, but Nicole certainly seems to be able to hold its own here. This dark brown patch you see, that's actually a lot of dry air that's entrained in between the two systems. You can also see the nice dry air that's coming in over the northeast, and we do have this trough that's swinging across the Great Lakes. That's not going to be really doing very much. It's going to pass an arm of moisture up to the northeast. The main action is still way back here in the plains. This is the weather system that models early on were trying to show as being deeper and stronger. Most, but not all models were showing that, and taking Matthew up the coast, and then as that trough got a little weaker, it showed it turning more out to sea, and now that trough is forecast to be so weak that it's not going to be kicked out by the global models. At least there are models that are still showing that, but the global models are saying no, that trough is going to be so weak that Matthew is going to miss it and wind up orchestrating some sort of a loop. Now, there's a little bit of debate on the models this afternoon with regards to that, and I want to show you. We're going to do the European model first. And one of the things on the European model, now you have to remember that there are going to be subtle differences going on from model run to model run, and even a slight change in strength in the trough in the north is going to make a little bit of a difference here. Now, we are looking at this. This is for tomorrow morning, 8 o'clock in the morning. Now, here's Matthew on the Florida coast, somewhere near or just north of Daytona Beach, and you have the trough out here in the west, which is a little bit deeper, just a little bit deeper than it was a day ago. And in fact, when I first looked at this and I saw the change in the depth being a little deeper, kind of raised my eyebrows a little bit, because if that trough were to stay deep, you can pick out the natural path for this would be around the periphery of the high. Now the high would be weakening, so I have it drawn too far west in terms of that arrow. That would assume if the high was the same strength, but as that high were to weaken, then Matthew would have taken a course something like this. But the models, and this is the European model run, goes back to flattening it. But one of the changes is that because the trough here, yes, it's flat, but it may be just a little less flat. That allows, by the Europeans' view, and also the UK Met supports this, by the way, which is the British model, Matthew winds up being a little further north. Instead of being, say, someplace down in northeast Florida, or perhaps just off the southeast Georgia coast. The European has it a little bit further to the north. So that slight change makes a difference. Now, here's the trough in the north, getting ready to bypass it. Now, we'll move along, and you'll see on the next one, there's the trough, and here's where you start to get a little dicey. And honestly, if this were, if it weren't for Tropical Storm Nicole somewhere out here, this trough should have been enough to pick Matthew and take it out to the east or east-northeast. But it seems that Nicole is the reason why that is not going to happen, at least initially. And as we move on with the Europeans run, and again, we're looking at it aloft, it settles Matthew somewhere down here. So it actually orchestrates a broader, attempts a broader loop. The problem now in the forecast, according to this model, is the fact that we have another broad trough approaching the middle Mississippi Valley. So it would seem that on the European, anyway, that the loop is not completed. It only gets so far, and you can see now the representation of Matthew as the trough, the first trough goes out. Here's the second trough, okay? And here we have a ridge of high pressure aloft. I'm going to run out of space, but there's your ridge, and it's kind of sitting in no man's land here. So now with this trough approaching and moving east, and winds along the southeast coast of the United States gradually forecast to turn southwestward, the natural thing for this to do is to move out, and that's indeed what the European does. It brings that trough further east, and then it kicks Matthew out to sea. And in fact, you can see that it actually then digs another trough late in the game. There it is, and let me just mark it out for you. So it digs this down into the southeast late in the game, but by that time, of course, there are no tropical systems around. Again, this is the new European's view on all this. Now, I want to show you how it looks on the surface, and then I'll show you the GFS loop, which was remarkable in a lot of ways if that were to wind up happening. And I have to tell you, given the GFS's volatility, I'm going to have a tough time believing what it has. I'm not saying that it can't be right, but it does seem to me that its track record lately isn't very good. So we have to, and we're going to have to take each model run one at a time because the volatility has been too much. And we've been saying this from the very beginning that models, not just now, but for the last month or so, going back to her mean, have been extremely volatile. But there's the surface low. There's the surface with Hurricane Matthew, and by the way, there's Tropical Storm Nicole. I can't show you the in-between because of licensing and copyright issues, but I did see it, and it does take the hurricane inland and just over Jacksonville eventually, and there it is over Charleston. Now it's southeast of Hatteras. You can see it moves southeastward from there, then it keeps going southeastward. We are now, by the way, in time frame, we are next Tuesday. And then from here, it kind of jogs it a little bit northwest as it waits for that upper trough to come, and then it starts to move it away to the northeast. To be honest, that's that's probably the more logical thing to happen. But I'm, questioning the strengthiness of the trough that initially causes this hurricane to be pulled slightly further north, which makes the low loop in a broader way, and then it gets caught by that trough in the next system that's coming in from the west. Now let's look at the GFS, which was beyond description, as I said. The GFS, I'll do it with the moisture on it because that's, I think, a little bit easier to see than with all those colors. And by the way, I want to mention, I want to state, these are, we're going through model outputs. Please listen to your local officials regarding, if you're watching this from coastal Florida, pay attention to the warnings. Please follow the recommendations of local officials regarding evacuations, and so on. Okay, that's your deal. I can't really help you with that. Okay, I'm looking at the forecast end of it here, and here is Matthew on the GFS. Now, when we have Matthew at 72 hours, it's just east of Jacksonville, whereas on the European, it's already almost to Charleston. So you can see there's the huge difference from the two models in terms of positioning, and that's probably why the European does what it does, because it's able to get the system further north, whereas the GFS is not, and does not get it as far north. It begins the loop just as it's moving off the Florida coast. Okay, so when we watch it here, this is Saturday morning. It moves east. It's a tight clockwise loop, and there's Nicole, by the way, here on the GFS being drawn westward, and now in this frame, in the sphere of influence of Matthew. In fact, you've got two isobars that are kind of linked together between the two that go around it, and you can see what happens. Matthew makes a very tight anticyclonic or high pressure or clockwise loop and goes southwestward into Florida, while Nicole just kind of sits here and then continues, by the way, to move southwestward. Now, a couple of things that I think are really important to point out. First off, when it moves off and then moves southwest, it's likely to weaken some. And the reason why, among other things, is that there will probably be some stronger wind shear. Upper level winds in the higher atmosphere will be stronger, and they tend to rip the thunderstorms apart. It doesn't allow the storm to maintain a certain degree of symmetry. The winds aloft being stronger wind up blowing those tops and tilting the system. And then if the shear is very strong, it could actually just rip the whole thing apart, and all you wind up left with is a low level circulation. But you will have a shearing issue, and you will also have the fact that Matthew will have upwelled a lot of this water and will have probably cooled it by a good 4 or 5 degrees, and that's going to make a big difference in terms of being able to maintain any kind of hurricane strength. And in fact, the GFS actually weakens it to a tropical storm as it moves southwestward. So that's a consideration as well with regards to what kind of strength you'll be dealing with if we get this very tight loop. Okay, and we don't know how far north the models are going to get. And by the way, also bear in mind, as we've gone through this forecast process, we've already seen over the last number of days having the models not far enough left, because many of the models, including the European, and in fact in a big way the European, it was one of the last models to come westward, had this going well offshore of Florida. Even as recently as yesterday, some of the models had it 60 to 90 miles east of the east coast of Florida, and now it appears, based on what we're looking at, is that most of the models take it just inland of the coast. So we've got to understand here that the subtle differences in the short term are going to make for larger differences in what we get in the long term. So we'll just have to keep going on with our next model run. A reminder again, this is a severe hurricane, a Category 3 with top winds from earlier at 120 miles an hour. Conditions are favorable for strengthening in the Bahamas, and we could see this become a Category 4, which is a very, very dangerous hurricane. And I think it's always wise to take the safe route with these things when it comes to, if you're along the coast, you really should need to heed the recommendations of local officials. We'll wrap it up. I'll show you a couple of the hurricane models. We have the HWRF model, which keeps it offshore, and it's not going to go out long enough for us to see the loop motion if it has one. But this model from today continues to insist that first trough picks it up and takes Matthew out to the northeast, which were the original solutions of the global models. The GFDL model is another hurricane model that we look at. This one, on the other hand, was one of the few models that was further west with Matthew, and it takes it right to the coast as a borderline Category 3, Category 4, and actually takes it further north up to Cape Hatteras, and also takes it to the east out to sea. So we do have some hurricane models still indicating that this will go up and out, that this first trough coming through will be strong enough to pick it up and kick it out. And we have the global models saying no, this is going to either do a very tight loop or some kind of loop, or a three-quarter attempt at a loop off the southeast coast of the United States once it moves inland and far enough north into the Carolinas. And by the way, for the Carolinas, you would have to really keep a close eye on this for North Carolina especially, if only because of the fact that if the Europeans right, it would bring tropical storm and possibly hurricane conditions to coastal areas into North Carolina, where the GFS would not bring it that far north. So you need to really pay close attention to the weather over the next 48 hours to see what track exactly develops from Hurricane Matthew. So don't forget, latest weather information, meteorologistjoechaffee.com, weatherlongisland.com, nycweathernow.com. SS Storm Chasers will be on the scene, gathering pictures and videos of Hurricane Matthew as it makes its way toward the United States.